Okay, so now we're working on the number 12. You have 3x squared minus 4x minus 4, and you have g of x is x minus 2. What you're doing is your division f over g, and so this would be 3x squared minus 4x minus 4 over x minus 2. So what I want to try on this one as a guess and check is if we have an x minus 2 down here, then I want to try an x minus 2 over here. Alright, so as I was saying, if you have an x squared term here and a linear term here, we can guess and check this way and see if this can actually be factored from this into these two terms. So let's see, if this is 3x squared, then we'll try 3x right there, because 3x times x is 3x squared. Okay, and then for this part, looks like we need a negative 4 for the last part. So far we have a negative 2, so that means in order to get a negative 4, we'd have to say negative 2 times positive 2. Again, this is just a guess and check, so now let's test every single thing. X times 3x is 3x squared. The outsides are x times 2, which is 2x. The insides are negative 2 times 3x, which is negative 6x. So if you have 2x minus 6x, you do in fact get negative 4x. And then negative 2 times positive 2 is negative 4. And so this is the proper way to make it work. These cancel, and so it's equal to 3x plus 2 as long as x is not 2. So I did the top part like this, and now over here I see where it says except x equal to, and then greater than, and greater than. So it wouldn't be these, and as long as x is not 2, that domain is going to be like so. And so you're going to want 3x plus 2. So again, one more thing I wanted to show was if you go to your document, just to show you how similar these are, if you do 3x squared minus 4x minus 4 as your numerator, and then you do x minus 2 as your denominator, it's going to look like that, which is linear. We've talked before about you looking in your table, and at 2 it's undefined. But what I wanted to do just now was say, oh, we got 3x plus 2. Let's see if that really matched. 3x plus 2. And yes, it did. It just overlapped. So if you saw it in the video, it flashed red and now it's purple, because blue and red is making purple. And so now if you go to your table, every ordered pair should match except for at 2 where it was undefined, had 8, then this one was 11, and that's 11. This is 14, that's 14. So it works for everything except for where x is 2. Alright, so now moving on to number 13. Here we're doing g of x minus f of x, and so you're doing x squared minus x plus 5 minus parentheses 5x plus 4. So again, you can add your opposite or you can distribute negative 1. So you have x squared minus x plus 5 minus 5x minus 4. So these would be your combined like terms, x squared minus 6x, and this would be plus 1. So we get x squared minus 6x plus 1. And remember, just like for linear functions, this would be all real numbers. For a quadratic, this would be all real numbers. And for the result, which is also quadratic, this would be all real numbers. And so there's no limitations at all anywhere. And so it's going to be all real numbers for this one. Make sure you look at every piece, because if it were undefined here, but not for here, you'd still have to put it. Okay, so now for number 14, we've got two linear functions, and it's f of g of x. So when you're doing f of g of x, that means you're going to start writing your f function, so 2 times something minus 1, and then you put your g of x here, x plus 7. So either start writing the f function and leave space, or just automatically put this into here. So this would be 2 times x plus 7 and then minus 1. So either start writing the f function or insert g of x for x. Insert or substitute that. Okay, so now you have to work it out, and you distribute, so you get 2x plus 14 minus 1.
Pardon the interruption. At this time, please release all early bus riders. Please release all early bus riders.
So you get 2x plus 13. And remember, most of the time you're not going to get the same answer for these, so now we have to go the other way. So if we do g of f of x, that means you'd go the other way, so you'd say something plus 7, and then put 2x minus 1 right there. And so this would be 2x plus 6. Okay, and then for this one, you're doing f circle g of negative 2, which means you're doing f of g of negative 2. So that means you're putting negative 2 into the g. So again, think of it as you do the number closest to the letter. So you want g of negative 2 first, which would be negative 2 minus 6, which is negative 8. Then you put your negative 8 into here. So f of negative 8 equal parentheses negative 8 squared, which is 64. Okay, and then for this one, you've got a linear function and you've got a rational function, a reciprocal function. Actually, I said that wrong. This would have been 1/3 x minus 1/3. So this is linear and this is linear. Okay, so what we want to do is f circle h of 4, so we do h of 4 first. So that'd be 4 minus 1 over 3, so 3/3, which is 1. And then do f of 1. So you have 2 times 1 minus 1 is 1. So that's how you get it. Now on 17 it says graph the relation and the inverse. So you know we use y equal mx plus b, and so we start with 5. And then our slope is 2, so we go up 2, and then over 1, put a dot, up 2 more over 1, and then if you go back to here, go down 2, left 1, etc. And you can use your protractor for a straight edge. So this is your y equal 2x plus 5. Now, for the inverse, one way to do it was you just have your xy and then switch it. So one way is like that. For example, if we put 0 in, we got 5, and you have 1 here. 2 times 1 is 2, plus 5 is 7. So if you have that, then that means this would be 5, 0, and 7, 1. So 5, 0, and 7, 1. So this is f negative 1. It doesn't ask for the equation, so if you want to just leave it that way, you can. These would just continue, this way, they cross. The other way is to say y equal 2x plus 5, so x equal to y plus 5, and then start solving for y. So you get x minus 5 equal 2y, and then divide by 2. So this is f negative 1 equal x minus 5 over 2, or you could say 1/2 x minus 5 halves. So 5 halves is 2.5, which is about where that line hit. And then you go up 1, right 2. So y'all may just want to plot 2 points and then switch it and graph it. That's all it takes. Okay, and then for the next one, you've got to graph the relation and the inverse. This one will not be on the test because this says blue and this says red. So I will throw out extra practice D. Now I know that when I do x minus 6 squared, that'd be to the right, and then it's probably going to end up being D. Yes, it is. So basically, just show y'all something real quick. If you have y equal x minus 6 squared, then x equal y minus 6 squared. So I'm going to have a new document, add graph. Function 1 is going to be x minus 6 squared, which is there. Now watch this. When I go to tab, now I'm on F2, but I have it solved for x. So all this chapter we've been talking about relations. So if we go to menu, graph entry edit, and then go to relation, now I can do whatever I want. And what I want is x equal, so I push the x down here and then I'm going to put equal. So x equals parentheses y minus 6 squared. And now I'm to the right. And if I just bump this up a little bit, then there you go. That's that graph. So if you look in the graph, you can see it's at 6. Okay, but again, that one will not be on the test because it says blue and red. Okay, now this one, you're doing your Celsius to Fahrenheit conversion. And so find the inverse. Is it a function? So I'm going to start with saying y equal 9/5 x plus 32. So now I say x equal 9/5 y plus 32. And we're going to subtract. And now I want to multiply by 5/9 to have that cancel. And so now if I just changed my terminology or my variables, it's c equal. So this would be c equal 5/9 f minus 32. In other words, you've got to take 32 away from the Fahrenheit and then about half of that. So Fahrenheit is always a bigger number than Celsius. Okay, so now is the inverse a function? Well, it's just linear, and if it's linear, then it is. And now it says use the inverse to find the temperature that corresponds to 35. So you do C equal 5/9 35 minus 32. So that's 5/9 of 3. And there's so many different ways you can do that. It does want 1 decimal place, so we need to keep that in mind. So because of that, I'm just going to go to my scratch pad. I just hit this button twice. And I'm going to go to 5 divided by 9 times 3. Now here's the thing. If all I did was push enter, it's going to have it as a fraction. I'm going to press up a couple of times to go back and highlight it and press enter. So what I usually do is I say control enter, because there's the little approximate sign and that makes it a decimal. And so then we just round and it's 1.7. The other way to do it besides control enter is if you go to menu, number, convert to decimal, and it looks like that, and you get the same thing. So if we convert that to a decimal, this is 1.7. Okay, because this was 1.6 repeat, because that was 5/3. Okay, anyway, on this one we have 1 over x, and we want to find the equation of the inverse. So on this problem, if we have y equal 1 over x, that means x equal 1 over y. Well, the funny thing about this one is when you multiply by y, you've got yx equal 1, and then you divide by x, and you get y equal 1 over x. Same thing that we did to begin with. So in this problem, the inverse and the regular function are identical. So this is 1 over x for both the function and the inverse. Now, as far as your domains, how it works is these two are the same and these two are the same. So for our function, which is 1 over x, it's going to be all reals except x not 0. And so that's A. And for our range of the inverse, it's like the range of the regular, so this would be y naught 0. So if it's talking about domain, it would be x, not y. And if it's talking about range, it would be y, not x. It's an easy way to remember it. And then this is a function because it passes the vertical line test. And if you remember, the graph of this looks like this. This is the one I described as you're going here and then you're making a left turn. Or you're here and you're making a left turn. So this is called rational, but we also say reciprocal. It's 1 over x. Okay, now our last one is find a formula for the inverse of f. So again, our first step is just call it y. It's the cube root of x minus 5. Switch x and y, so we've got x equal the cube root of y minus 5. And then how do we get rid of that cube root? The only way to get rid of that cube root is to cube both sides. And so that means this is x cubed equal y minus 5. And then just add 5. And so that's your f negative 1. X cubed plus 5. All right, so that's the end of your review.